Hello everyone, welcome to Java LeetCode series. Problem number 238, product of array except self. It's a medium range problem, but the solution can be obtained very easily. We'll go through the question once. Given an integer array nums, so an integer array nums would be given where we need to return an array answer, okay, such that answer I is equal to the product of all the elements of nums except nums of I. So as you can see here, we have nums 1, 2, 3, 4. So nums of I, if we consider the position 1, nums of 0, the value at here would be equal to 2 into 3 into 4, which is 2 3s are 6, 6 4s are 12. Sorry, 6 4s are 24. So that's the reason we have 24 here. Similarly, if we take 2, so nums of one position, now it's 2. So the answer should be 1 into 3. 3 into 4 12, so that's why we have 12 in this position. So basically what they are saying is we need to have the product of all the elements at that particular position except itself. Okay, even if you see here, uh, uh, the number is 3, right? So 1 2s are 2, 2 4s are 8, so that's why we have 8 here. And if you see the last number, it's 4. So 3 2s are 6, 6 1s are 6. So that's the reason we have output as 24 12 8 and 6. Okay, the product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. So okay, it's guaranteed that it's an integer. You must write an algorithm that runs in O of n time and without using the division operation. Okay, this is a trick here. We shouldn't use the division operation. If we had used the division operation, it would have been like more quicker one, but they are asking us not to use the division operation. Okay, then what we'll do? Okay, so we'll have this interesting approach. Let's consider the position 1. Okay, so at the position 1, uh, what we'll do, we'll try to create two arrays, okay, such that one array contains all the left side values, other array contains all the right side values. Okay, and we can just multiply the corresponding values of left side array and right side array, and we can get the number. Let's see it with the 1. So we have 1. So the left side array, we don't have anything, so let's consider it as 1. Okay, so the right side, we can multiply 2 3 4. Okay, so 2 3s are 6, 6 4s are 24. Okay, the value 24 can be in the right side array, and the value 1 can be in the left side array, because we don't have anything left to 1, so we can have it as 1. So 24 into 1 will be 24. We can understand it with this example also. 2, if you see left side, if we create a left side array, let's suppose we have 1 in the left side array and corresponding value, and correspondingly in the right array we have 3 4s are 12. Okay, so to get the value of 2, we can multiply 1 into 3 4s are 12, right? So it will be 12. Okay, it's as simple as this. Even for 3, if we consider, so the left side, we have 2 and 1, so 2 ones are would be 2, that will be stored in left side array, and 4 in the right side array. So they will be multiplied. 2 4s are 8, so that's why we'll be getting 8. Okay, let's try it out. Let's try to create two arrays, left side and right side, and let's try to multiply the corresponding element. Okay, uh, we'll create two arrays. Int left is equal to new int, let's give the size of this array. It will be same as the nums, so nums dot length would be its size. Okay, then we'll create one more array, which is the right array. Right is equal to new int. So this also, let's copy it. So both are basically of the same size. Okay, let's create some variable here. Let's say it is start is equal to 0, or better, we'll have it the we'll have the first variable in the left array. So we'll say int left is equal to 1. Okay. Okay, we are having the value of maybe we can remove this int. Okay, the first value of the left array would be 1. Why so? Because if we see here, at this particular position, like I is equal to 0, we can see left side there is no element, so we can consider the left side element as 1. Because if you see here for 2, the left side element already it's 1. Okay, so but for the 1, we don't have any left side element, so we are considering the left side array element as 1. Okay, then we'll write a for loop for int I is equal to, we'll start from the 0, and I less than, will iterate through the nums dot length and I plus plus. Okay, then what we are going to do, so we are going to fill the left array with the uh, left side multiplication. So we can consider left of I is equal to, we'll be storing the left of I, left of I minus 1. So the previous element multiplied with the nums of I minus 1. Okay, let's check for this. So if suppose I want to find the left side of this 2, so left of I minus 1, in the left array, I already had the default value as uh, okay, let's take it for the I is equal to 0, maybe this condition. So here you can see, so left of I minus 1, I minus 1 would be 1 minus 1 would be 0, so left of 0 already that value is 1. So the new array, it contains 1 into nums of I minus 1, so that value is 1. So 1 into 1 would be the value in the new array in the first position. Okay, I'm not just typing it here. I hope you can understand it verbally. Let's consider for I is equal to 1. In that case, this would be the element 2. Okay, then left of 1, left of 1 value would be according to the condition which we wrote, left of I minus 1. Initially the left of I minus 1 was 1, so now 1 would be multiplied to nums of I minus 1, which is also 1. So even if we don't have to go through this much brainstorming, you can simply understand this left array is storing the elements left side to the number we are going to iterate, number we are going to uh, take the left array for. Okay, so let's suppose for 3, that for this condition would take all the multiplication of the left side elements 2 into 1, which is basically 2. Okay, then after completion of this loop, we'd be ending up with an array which consists of the left side elements for the given elements. Okay, then again, um, we'll take this time something okay, as right, so right side array now we are going to take. Okay, right side array nums dot length minus 1. Okay, the last element in the nums, the last element in the right array should be 1 this time, because if you see that for the number 4, the right side product would be there is no right side element, so we can consider 1. So that's the reason I'm taking right side. We have 1. Then we'll again go through the same loop, but this time we won't have the loop from the starting. It will be from the last second element, because last in the right side array, I mean this is not the right side, but let's just consider in the right side array, i- like the first value would be 1 and the second value would be right side product would be, if we take for this 3, it will be 4 into 1. Okay, so that's the reason we'll start it with the nums dot length minus 2. So we are starting with nums length minus 2, which means we are starting with the second most element, and I greater than or equal to 0. We need to iterate through the uh, entire nums array, and also I minus minus this time it would be. Okay, in this what we are going to do, so we are going to take the right of I. So this will be equal to right of I minus 1, okay, into nums of sorry, it shouldn't be, we are taking increment, right? So it should be right of I plus 1 into nums of I plus 1. Okay, so that's it. And later we need to just have another loop where we'll multiply for the corresponding arrays. So int I is equal to 0. We'll take the normal loop here, and I value less than nums dot length and I plus plus result. I didn't initialize it. I'll do it above. Result of I is equal to left I into right I. Okay, so we'll create one more array here, which is the result array. So int this result array would be the same length as um, the same length as the other two arrays. So nums dot length length. Okay, I hope this works fine. Wait. I think we didn't yet return anything. So what they are asking to return? So they are asking to return uh, integer array. So return result. Okay. So let's see if it works. Okay. It says index out of bound. I is equal to 0. I less than nums length. Okay, okay, first element we have already used, right? So it should be I is equal to 1. Okay, it got accepted. Let's try to submit it. Okay, okay, you can see it got submitted, but we are not good with the memory part. So let's do one thing. Instead of using these many arrays, we'll use the only left side array and the result array. Only we'll try to use the two, and others maybe we can remove this right side array. So what is the logic in removing the right side array? It's simple. When we get the left side array, so we can simply have some variable. Okay, let's suppose at position 3. Okay, at 3, I mean at index 2 we have 3, right? So the left side array would have contained 2. value 2 in it. So the right side array, what it was doing earlier, it was just having the value of 4. So instead of having an array, what if we just have some variable, int variable, which will just store the uh, values from the right side, maybe multiplication of values from the right side. It would be better, right? So what we can do, we can have the left side array as it is, but instead of this right side array, wait, instead of this, we can have a suffix here. Int suffix, this is just name of the variable. Int suffix is equal to 1. So we are going to do the same. I'll copy the result of I. Maybe I'll remove it. We don't require it because we are doing everything in the one array left array, so we can remove this. Okay, we can also remove the result, or we can also comment it. Okay, so we are initializing suffix is equal to 1. Then for the same condition, okay, we'll remove this. Okay, so this suffix suffix suffix, okay, we need to have it multiplied, right? The right side value should be multiplied. So suffix is equal to suffix into nums of I plus 1. Okay, so what does this mean? I Let's suppose for the 3, for 3, the left side would have contained 2. The right side, instead of using the right side array, we are using the suffix. So which stores the value of nums of I plus 1. So in here, as you can see, I is equal to nums dot length minus 2. So which means the same element. So it will be multiplied with the 4, which matches with the earlier scenario. And instead of using an array, we are just using the variable here. Okay, then in the left in the left array itself, we'll be multiplying with the, okay, we'll have left is equal to, okay, so which means left of I into nums of I. I think already we have taken nums of I plus 1 above, so we can just multiply it with suffix. Okay, so whatever the value we are getting for the suffix, we are multiplying that with the left array, which is already having the element in it. Okay, and we can return directly left array. Okay, let's try to run this and we'll see. Okay, it got accepted. Let's try to submit this. Okay, and we are even able to make good with memory also this time. Earlier it was very low. Okay, so I hope you guys have understood the logic. Okay, let me iterate this one more time. So we are just taking a, instead of taking right variable, we are just taking a suffix. Okay, this suffix, it contains the multiplication of right side elements. Let's say for position 0, I mean for the index 1, this suffix will contain 3 fours are 12. Okay, as you can see, suffix is multiplied with nums of I plus 1. So this suffix will contain the right side multiplication, and that will be multiplied to the left side array, which already has the, if we consider for 2, the right side, the suffix contains 12, and the left array value would be 1. That's why 12 into 1 would give us 12. Okay, I hope you guys have understood this problem. Let me know in the comment section for any doubts regarding this problem. Thank you.